Hello, everyone. Hello.
Hi.
Hello, Professor.
Hi, Professor.
How are you all doing?
It's hot.
Good.
Hot?
Yes, very hot.
It's Michelle. You are driving. Are you sure it is safe for you to be
It's
in?
safe. I got the hands free.
I'm gonna get you, girl. You can't keep doing that.
It's Michelle. Is it a self-driving car or
Huh?
is it a self-driven car or what?
Yeah, I got Tesla. It's like, I don't
Oh,
want
Tesla.
I'm lying. I don't want y'all to see me
Careful.
outside like that girl was
Be
lying.
careful. Be careful. That's what I'm saying. Be
Okay,
careful.
I'm
Yeah?
tuning in.
I want you to be safe.
I
Okay?
am. I'm gonna be safe.
Okay. I just want to make sure.
Okay.
All right.
She said she clocking in the class.
And you know it.
Okay. Let us begin. Yesterday I introduced you guys to how to draw histograms, how to draw histogram and other charts, bar chart, histogram. Today we'll be working on something which is a continuation of data presentation. We start with the stem and leaf plot. But before we went into that, before we go into that, I want to introduce you to something else, which is very, very important. And we call it the shape of a distribution. The shape of a distribution. Now, give me 1 minute. I think there are some people who are trying to join us. They're in. Okay. Now, you can see the screen. You can see the screen, right?
Yes.
Okay, good. Okay. Good. Now, most distribution that we have, like the one I showed you yesterday, have what we call humps or peaks.
Sorry, sir. Are we recording?
Yes, it's recording.
Okay.
The humps that call peak, like this one. See, this is the tallest, as they call a hump or peak. So good example is in a restaurant, let's say McDonald's, in the morning, there may be slow sales might be slow, but once you get to the noon time, sales will shoot up for lunch time. After which sales volume will now go down. See that peak is what we call it the mode. So now a distribution that this one has only one of those peaks, one mode. We call it a unimodal distribution. Unimodal because it has one mode. So unimodal. Good example. I'll give you an example with a restaurant like McDonald's sales. How about seasonal sales volume in a retail store during Christmas? Before the Christmas, a few months before the Christmas, the sales might be slow. But once it comes to Christmas, you start to see the stores doing sales, 40% off, 30% off, which will bring in more people to the store to buy. And you see the sales shoot up, reaches a peak. Then after the Christmas day, it starts falling down. So we said it has one peak or one mode, and we call it a unimodal distribution. But there are some distributions that have two peaks, like here. Let's say that somebody who is taking a blood pressure medication, it goes up, your blood pressure goes up, and you take the medication, it goes down. Maybe later in the day, it goes up again, reaching the peak, you take a medication, it goes down. So two peaks. Another way you can illustrate this with a real life example is sales in the restaurant. Let's say that it goes up in the summer in the lunchtime. Then after the lunchtime, it goes down. Then the evening time, which is the dinner, I believe that's what it's called, right? Night meal is dinner, right? Am I right or wrong? Hello?
Sir, yes, sir. You're right.
Yeah, so that dinner time, you see the sales shoot up like around 5 p.m. Then after the dinner time, it goes down. So you see, you have two peaks. You call it a bimodal distribution because it has two modes. Now, how about this? During Christmas, before the Christmas time, we have the Thanksgiving holiday. So sales in Walmart might go up in Thanksgiving holiday. You know, when we have a Black Friday. Then when we have a Cyber Monday, it goes up again and then down. So that's why I have 2 peaks. Now, many distribution can have more than 2 peaks. If I use sales, for example, we have many sales. We have Thanksgiving sales, we have President's Day sales, we have Easter sales, we have Christmas sales, Cyber Monday. So during those times, you see them going up and down. Sales shooting up. So you can say that more than 2 modes. We have call it the multimodal distribution because it has 2 modes. Another example is somebody that have a diabetes, for example. Blood sugar goes up, you take medication, it goes down. It goes up, you take medication, it goes down. Or even somebody that doesn't have diabetes, when you eat, your blood sugar goes up. Then as you are active, it goes down again because you burn the sugars. When you eat something again, it goes up and down. How about the stock market? Keep going up and down. So we call them, it has multiple modes, and we call it multimodal distribution. I use blood sugar here as an example, but there are many real life situations that reflect this kind of distribution, like the sugar fluctuation in a diabetic patient, blood pressure fluctuations, movement of stock prices, sales volume during different holidays. These are multimodal distribution. During that time, sales, you have a peak and it goes down again, peak, down, peak, and down. Questions on this?
No, sir.
Now we can look at other types. The one we call uniform distribution. In that case, there's no peaks. They have the same size. A good example is this. Suppose somebody wanted you to participate in a survey, and it says, if you participate, they will pay you $50, or they will give you $50 gift card. For anybody that participates in that survey, they give them $50 gift card. So the first respondent will be, I used 50, but you can use $25 gift card. That's what I drew here. The first respondent will get $25 gift card. Second one get $25 gift card. Third one, so they all get the same thing. So they call it a uniform distribution. There are many real life situations that reflect this. Okay. Then this will now lead us to what we call skewness and symmetry. This type of distribution, this is the type of distribution whereby the data values are uniformly distributed. In that case, we call them symmetric distribution, where the data values are distributed uniformly. Just like your body, if you can cut half of this, you can see that they are the same on both sides. They are like twins, mirror images. So now we said that such distribution are said to be barrel shaped like a barrel, has a single peak, and tapers at both ends. Look at it right here. Have a single peak and tapers at both ends. And when you graph it, it's gonna look like this. So you say that this is normal or symmetric, or normal, symmetric, or there's another thing we use for this, which is uniform, no, not uniform. Normal and symmetric, basically, that's what it is, normal distribution. So it tapers at it's a peak at the center, but it tapers at both ends. I'm going to use an example to illustrate this. If you get every adult in Maryland, every adult person, male or female, all of them, and graph their heights, it will give you a smooth curve like this. Now, if you get everybody that have normal blood sugar, and of course, they won't have the same number, but there's a range for normal blood sugar. But above that range is not normal anymore, or below that range is not normal. But the people that have normal blood sugar level and plot their graph in, I'm talking about for the whole of Maryland, but it has to be a population, or even the whole of Baltimore City. So long as it's a population, it will give you a smooth curve like this. So we say that it is normal. Many variables in life are normal, follow normal distribution. As we're going to do more work on normal distribution later on in this class. Now, but sometimes we might have some what is called skewness in a distribution. I decided to do this shape of distribution because we did it with our histogram and bar chart. So they are the best type of charts to use to illustrate these shapes. So in a skewed distribution, you will see that that one tail of the distribution stretches further on one side. For example, here, you can see that it stretches more on this side, on the right side. See? From the peak than on the left side. The left side is dropped very quick. So if you plot it, it's going to look like this. So it stretches more on this side than on the left side, as you can see from here and here. So we say that because it stretches more on the right side, we call it a right skewed distribution. A good example of this in real life is income. Now I use blood pressure here because blood pressure can also be used to illustrate this. But let me use income. Income is usually right skewed. If I plot the income of people in Maryland in a bar graph like this, you will see that we have more people with low income than people with high income. I mean, we have more people that makes less than 100,000 a year than those that make more than that. So you can see that more people will concentrate on this left side, on this side here. As you go to the higher income, the population of people that make 1 million or 10 million a year is lower than the population that make less than 100,000 a year. Another way of saying is that we have much more poorer people than richer people. So you can see that income always have a right skew distribution. Since the left side is more people are concentrated here because more people make lower income than those that make higher income. I mean, you can count the number of billionaires in America, but you cannot count, it's very hard to count the number of people that make less than 100,000. That is a much more bigger task. Now, another example I can give you is this. If I give a test that is very hard, you see that when it is, more people will score 30%, 50%, 10%, and less people will score 90% because it's a difficult test. So a difficult test have a right skewed distribution. I mean, you can think of other things, in life. Now let's look at less skewed. For the less skewed distribution, you can see that it stretches more on the left side than on the right side. Okay, see? And if you draw a line graph on top of this, you can see that it goes up, then it drops, see? A good example is when I give an easy test. The exam is easy. You see more people scoring 90s and 100s, and less people scoring 10% and 20%. Questions on this? Any question for us?
No.
Good. Very good. Now let's look at outliers. Outliers, simply we use it to describe a data value that is standing out. It is either it is extremely high or extremely low. So I'll give you an example in real life. When it comes to retail shops, retailing, both online and offline in America, Amazon is an outlier. Their performance is unique. They're unique. They're basically disrupting big stores like Macy's, Walmart, and so on and so on. Even Walmart, to some extent, is an outlier. How about this? If you go to a place like a low-income neighborhood, a neighborhood inhabited by low income, I'm going to use Baltimore City as an example. Like North Avenue neighborhood. We have more of low income people living in North Avenue. Now, if you see somebody who is a millionaire living in North Avenue, that means it's an outlier. It stands out from the group. So it can be, it can be low income or high income, depending on what the kind of data set you have. Outlier can be somebody who make extremely low income as well, or extremely high income. Now, somebody most people have normal blood pressure, but sometimes we have problems. When we get older, naturally our blood pressure increases. However, but young people usually have normal blood pressure. But sometimes we have somebody, for some reason, a teenager started having high blood pressure. That person will become an outlier. Okay, there is a reason for that. Now, another example is this outlier. If I take any of you here in this classroom and put you in a first grade class and give us a first grade exam, your score will be very high than the rest of the class because you are an outlier. So outlier stands out from the group. This is how we represent the outlier in a histogram. See, this is the outlier right here, stand separate from the group. See? For example, if this question says, let me see if I can push this down so that we can solve this question. See, look at this. It says, the following graph shows annual income of the resident of Baltimore City. Describe the shape of the distribution. Now, if you look at this distribution, you can see that it stretches more on the left side than on the right side. And it also has two outliers on this left side and right side. So I will say here, explanation. Okay, make it, see, I see it stretched more, a little bit more here than here. So the distribution is skewed to the left, and it has two outliers. That's it. So in your homework, they might ask you, they will give you the options. You choose the one that is correct. Questions for me? Any question? No, class, any question for me?
Sir.
Any question?
No questions.
Yeah, I have a question.
Sure, go ahead.
The distribution is skewed. You said it's skewed to the left. That's the explanation.
Because if you put a line here,
yes,
you see that it stretches more on this side a little bit than this. This one is more smooth.
Oh, okay.
Stretches more, so that means it's
yes,
left skewed.
Yeah, I see. Yeah.
That's all? That's all the question? Okay, good. So let us go back to our main work.
Yes,
good. So today we'll be looking at other data set. The one we'll be looking at is today is we have the stem and leaf plot. Now in a stem and leaf plot, we plot the actual data values we keep them when showing them graphically. We return the actual data values. It's more of like a histogram, but in histogram we draw the summary of the summarized statistics. But in a stem and leaf plot, we return the actual data values when we are trying to show them graphically. So let's look at how it's done. Look at this example here. It says the following are number of text messages sent last month by a cellular phone users or by cellular phone users on one floor of a college dormitory. Display the data in a stem and leaf plot. So usually what we have here, to do the stem and leaf plot, you need to first of all find which part is the stem and which part is the leaf. Now, let me show you how this can be done. For example, here, we have, you notice that all of these numbers have three digits. The last digit is always the leaf. Then the first two digits is a stem. So you can see right here, let me make it explain it more better than this. Excuse me, just 1 minute. Let me use this Word document to explain it. So what I was trying to say is, suppose you have 10 numbers like this, 8, 4, whatever it is called. Now, this first two number is the stem. The last number, which is 4, is the leaf. Now, if there are two numbers, we have, let's say 54 or 45 or even 78. The first number is your stem. So those ones that are yellow are the stem. Like for example, this one, this is your stem right here. Okay, let me say this is a stem. The yellow one, the ones that are highlighted. Stem. Okay. The ones on the other side is the leaf. Leaf. So that is the leaf right here.
Always, Professor.
The last digit is the stem, is the leaf.
Right. No, what I'm saying is, okay, and all the data sets that you have, say 155, the 15 is the stem and the 5 is the leaf.
You mean this one here, right? This one here, 50,
the
right?
first,
The first two is the stem, the last one is the leaf. Yes, you are correct.
right.
So we have, if there are two of them, then the last digit is always the leaf.
The leaf.
Mm-hmm.
Okay.
So if you have this here, you will see that the first number here becomes the stem.
Because that's on the test on the homework.
And the last number becomes the leaf. See?
Mm-hmm.
Now, if you have, let's say that you have 4 numbers. Let's say 2, 4, you know. In that case, again, the last number is also your leaf. The first 3 numbers become the stem. Okay. So this is the stem. So know that the last digit is the leaf. In that case, the stem becomes the one that I highlighted. Okay.
232.
Then the leaf becomes the last digits.
The 7. Okay.
Okay.
Yes.
Now, based on this information, we can now make the stem and leaf plot. The key to making the stem and leaf, the correct stem and leaf plot, is to first of all put the numbers in order from smallest to largest. That's one way of doing it. That's the quickest way, if you ask me. And the way that it is done in this place, this note, is another way of doing it. But that will take you a longer time, because after you have arranged them, you get the stem and leaf plot, then you start to reorder them again. So the best thing is to just put them in order here and get your stem and leaf. So let us answer this question now. I will take you to where I can show you the work. So now this is numbers, I put them here. Then in the second group, I put them in order from the smallest to largest. Okay. Now we can make our stem and leaf plot here. So 78. This 78 can be written as 078.
Right.
Because they're all 3 digits. So make it 078 because they are all 3, to make everything 3 digits. Okay. Now I have you can now have your stem. I'm gonna put it in this form. It's a form of a chart, stem and leaf. I have the stem. which I can move to this side, and their leaf. Okay. Now the stem. So this is the stem right here, 0, 7, which is 7. You can see that once you put them in order, the first 2 digits here is 7, right? First 2 digits are 10, 11, all the way down. As you can see, the way it is done in the hand, I can see right there. So I see 7, 8. Okay. Now we have it. Let me take you back. So you can see 0, 7. Now the first 2 digits are the stem. So you have 0, 7, 8, 9, 10. Now remember, it started from 0, 7, which is 7. There's no 8 and 9, right? But and next thing you see is 10. But you still have to put those numbers to show that, you know, they should be, you get 8 and 9 before you get 10. So if you look at the first 2 digits, if you look at the last one is 159, which the first 2 digits is 15. So it goes from 7 to 15. Okay. 11, 12, 13, 14, 15. Now 7. See 7, 78. You see the 7 after the leaf is 8. So you gotta put 8 here. I'll give you 78. Now 8, there's no number for 8. There's no number for 9. But for 10, we have 109, which is 10 and 9. So 10 is the stem and 9 is the leaves. That gives us 109. Put 9. That means 109, which is 109 here. Then next is 114. Where 11 is the stem. You see the 11 here. Next is the leaf.
Don't do anything with the 8 and the 9. Just leave it blank.
Because there's no number there, but you still have to put them there to show that you get 8 before you get 10.
Like a placeholder.
Huh?
I say the 8, 9 is there like a placeholder.
Exactly.
Okay.
So next is the 11, 114. See 1, 1. See put 4 right here.
Okay.
4. Then the next is 118. So 118. I usually give 2 gaps. 8. I have 121. That will start from 12. So 121. 121. Okay. 124. 4. I'll give you 1, 2, and 4. So 126. See? 126. 6. Then next is 13, which start from here. So you have 132. You know what? I think I missed I missed the the 10. See the 10s continued here.
Oh yeah, 105, 108.
Yeah. So but the good thing is that because I put them in order already, I can just put them here. Say 105. 105 should be here.
Okay.
Why? Okay. 105. Okay, we'll see 105 is gonna be 105. 105. So you have 5. Then have 108. See 108. 8. Then the 109 is twice. I think it's 3 times. 109, 109, and 109. So we have 1 already.
So you gotta put 3 of them.
Yeah. 9, 9. And that ends the 109s. So 112, we have 112 here, 112. So I started from here. I didn't put the 2, so we're gonna put the 2 right now. So 112 is 2 of them. So we have 112. There's another one.
Yeah.
112 right here. 3 of them, right?
What?
Okay.
3 times.
3 of them. So I put the 3 of them. Then 113.
Yeah.
Yeah. Yeah, before 114. You can see the 113, then 114, then 116. Yeah, 116, which is right here, and then 117. So 116, 117. Then we have 118, which we have here already. We have one of them, but there are 3 of them, so we're gonna put the remaining 3. 8.
And you got 3 9s.
So 119, 3 of them, right?
Yeah.
So 119. Then 121.
One
So,
more. One more.
See, 119 is 3 of them. 1, 2, 3.
3 of them.
Yep. See the 9 right here. 1, 2, 3. I got it. So next is 1, 2. Have 1, 2, 1, which is right here.
And you got
then I have another 1, 2, 1 here. Okay, good. Okay. Then I have 1, 2, 2. How many of them? 3 of them.
3 of them.
Have 2, 2, 2. Then 1, 2, 3. How many of them? 1, 2, 3 is only one of them. 3. We have 1, 2, 4. We have 2 of them. Okay. Then what else? Then 1, 2, 6. We have 1, 2, 3, 4 of them. So I have one already. So what else? What else? 1, 2, 9. 2 of them. See 1, 2, 9 here, 1, 2, 9. Okay. Next is 130. So 130, which is right here. I have only one of them. So 130 here. Okay, 130. Next will be 132, one of them. 5. 133, there are 2 of them. And we have 134, only one of them. 139 and 139, 2 of them. Okay. 140 and 140 is one of them. So I'm going to start from here. 140. I have 142, one of them. I will have 144, one of them. We have 145 twice. Then we have 147, only one of them. 148, only one of them. 155 and 159. 155 is right here. Okay, I see. Okay, I see what I'm gonna do. 155. Yep, 55. 155. 5, 5, and then 159. So now they can ask you to describe the shape of this distribution. If I ask you to describe it, now I want you to turn your paper counterclockwise, as I'm going to do now. Let me see if I have it right here. Layout. How can I rotate this? Rotation. Let's see. View. Let me see if I can rotate it. If you can turn it counterclockwise. Yeah. So I'm looking for the place where I can rotate it. It will show you that this is like a histogram, and it is right skewed with one outlier standing out. So let me see if I can page design. I'm gonna have to lay out, see if I can rotate it. Okay, see. Okay. Okay, rotate page. All right. Okay. Now, if you have this on your paper, if you can turn this like counterclockwise, you see that when you draw a line here, let me put this line here. Let me see. Let me show what I mean by that. If you draw a line from here see, and turn it counterclockwise. How can I rotate this? You would just discover that this is, you can see that it stretches more on the right side than on the left side. And it has one outlier. So you look at the outlier right there. See, 8 is standing out, there's a gap here. So you can see that it stretches here, the right side and left side. So we can say that our data set interpretation the data set. What I'm going to show you the page rotation in a few minutes is skewed to the right with one outlier, the number 8. Number 8. Let me show you why I put in this one. I've already shown you with this diagram. I couldn't turn it counterclockwise, but let me see if I can do it in the one we have on our notes book. So if you look at this, let's put me right here. Let's see if I can rotate this. Because this is the final thing they have. Like we have our own, we have our last testing as see the 5-9 yet. So I'm gonna rotate it. You see this doesn't work. Rotation. I think this is it. Okay. I've rotated. Can you see this? You can see that you should put a line here. I don't know if you can allow me to, draw a line. Okay, draw. Let's see if you can allow me to draw a line on this. Let's see. It won't allow me to draw here because this is PDF. But if you can draw a line here, if you can see that this looks like a histogram. So it goes here, up and down. Then you can see that it stretches more on this side. Okay, than on the left side. So that's why it says it is right skewed, and it has a one outlier here, which is the 8. Okay. Questions for me?
Nope.
No question. Good. Now let's look at the next one, which is the dot plots. Dot plot. In a dot plots, we use a dot to represent the data. So each data entry is represented with a dot. So, and if it repeats more than once, we put another dot on top of that. Like here, if you look at this one, see we have 26. See, there's a dot on 26. Now 25 repeated twice. See, there's a dot on 25. One here and one at the top. 36 repeated 2 times. See, there's a dot. That's the first one and the second one. So for our data set, this one here, if you want to plot a dot plot, make a dot plot. In this case, you don't need to put them in order. If you like, you can put them in order. The first one is 155. And the 155, you can see right here. 155 should be right here. You can see right, see the dots here. Then 159, which should be around here. You can see that dot. Now, if you remember, in our data set, there's a number that repeated the one that I withdrew on the stem and leaf plot. Look at this number I repeated. I got 112, 112, 112. So when you go to the dot plot, you're gonna see that we have, you see that we have 112 here, right? 112, 112, 112, and so on. So that's basically what it is, dot plot. So when you look at this dot plot, you can see that most of the data sets are concentrated in 105 to 148. That's where most of the data set are concentrated. So this is just a way of showing a data set. It's not, we don't use it most common. It's not commonly used. You don't see it most of the time. The one that are common are the histogram and the bar charts and pie chart. You know. Question on this?
Nope.
Let's look at the pie chart. So that's the pie chart. In this case, so we use the size of the sector of a circle to represent frequency. I'm sure that you guys must have heard of this mathematical tool that we call a protractor. I'm sure you guys know what a protractor is. I'm going to show you what a protractor is. I think I can pull it from a Google protractor that we use in our trigonometry class. See, it looks like this. Is there anybody who haven't seen this before? The protractor. Let me see the images. You know this, right?
Yeah.
So we use to measure angle. So for pie charts, we use that to draw pie charts. But the good thing is that the technology have made life very easy for us. But however, we still like to teach the principle behind it, because so that we draw it on the using Excel, you understand what the Excel is doing. So let's use an example here. Say the numbers of n degrees in thousands in year 2007 are shown below. It's a use pie chart to organize this data. See, associate degrees 728, bachelor's 25, and so on, master. So to draw the pie chart, remember pie chart is based on the same principle that the angle sum of a circle is 360 degrees. So that means we need to get the frequency, then relative frequency, then get the measurement in angle, then use it to measure each degree for each sector. So to do that, we begin by presenting a table of values, which is what we have here. We use this data here to present the table of values that will show you here, right here. And let me show you how these numbers are getting. These first two are already given to us. If you remember the equation, it says that associate is 728 and bachelor's is 1525. You can see it right here. Associate is 728, bachelor. So these first two are given to us. The one we need to get is the frequency, relative frequency, and then the angle. So this relative frequency represents the percent. The angle we use to get the size of each sector. So now let me show you how the numbers are got. If you know this one, to the total for this will be we have, let me write it down so we can get the total. So I got 728, 1525, 604, 90, and 60. So we add all this. Make sure I have all these right. 728, 1525, 604, 90, and 60. So we can then add them to get the total. From then we can get I think I opened a lot of things. Let's get our calculator. Okay. So I couldn't see the calculator here. I'm going to open a calculator from here since you can't see it from here. So the calculator is Desmos. Okay. So those numbers that I listed, we can add them together. You have 728. You can see this, right? Plus 1525 plus 604. Oh, excuse me, 604. Okay. Plus 90. Then plus 60. That gives us 33,007. Now since we get this, we can now begin to get the relative frequency. Remember that from what I explained to you a few days ago, relative frequency means the frequency divided by the total. For the first one, we have 728 divided by the total, which would be 728 divided by the total. We got the total as 3007. Okay. You got 0.24. 0.242, you have many decimal places. We normally stop at the second decimal place, which is 0.24. That is how they get the answer 0.24 right here. So to get the other one, we divide this by the total we have, 1525. Let's do it, 1525. We got 1525. Okay, 1525 divided by a total of 3007. 0.50714. So you round it to two decimal places to give you 0.51, which is what you're gonna see from our note, 0.51. So that's how we get all these numbers. You divide each of them by the total. So this 0.24 means 24%. This one means 51%. This one means 20%, and so on. Now, this is the relative frequency. Now, to get the angle that you measure using the protractor, you multiply each of these with 360. So 360 times 0.24 gives us 86 degrees, which means that for the associate degree, you measure out 86 degrees. Now, for bachelor's degree, we have 0.51 times 360. That'll give you 184 degrees. So you can see all these measures in this chart here. So you measure out, see the bachelor's, which is the largest, say 184 degrees right here. You measure it out, Now, so now this is the principle behind it. Now, the good news is this. Excel have given us a way to do them without doing all these calculations. Before I show you the Excel method, is there any question here for us? Any question?
Nope, I think you got it.
Are good? You're all good?
Yep.
Okay, so let me show you how to get it in Excel, directly in Excel. So I'm gonna write them down and then take you there to Excel. We have associate degree is 728. Bachelor's is 1525. We have master's is 604. First professional, okay, is 90, and doctoral is 60. So I'm gonna take you to Excel now so that we can put them in. The good news is that we now understand the principle behind it, so that we have it. I'm gonna go to the next sheet and make it a little bit bigger. So that will save you a lot of time. We have the associate degree, 728. Our bachelor's is 1525. We have master's 604. By the way, I sent you guys a message last night to subscribe, to enter into put you in my remind.com. I hope you responded. First professional, this is good that you respond so that you can get updates quicker. Even if you don't log into canvas and get the update. First professional is 90. And then we have doctoral. We have 60. These are in thousands, I believe. So now to put a pie chart, you can just highlight it and click insert. And this is the pie chart right here. I recommend to use this one. And you can see it right there. So it gives you the numbers right away. Now you can
How you get to the pie chart again?
Sure. Let me close this and then oops, yep, I have it right here. So it goes here. You highlight it first, right? Then click the insert. That's the one you're asking, right? Hello?
Yeah, that's what she's
That's
asking.
here. Yes, I am. So you go to insert.
And choose the chart. They have more updates. You can, if you like, you can have, if one more, you can just click on that and it give you more information on that. You can just, but I recommend the first one, this better one, first one. Okay, you should choose it and then click OK to give you the pie chart then. But you didn't have the numbers on it. So that means you can format it and but I don't know why it is not highlighted here. Maybe I can draw it on a different okay, in a different workbook. Okay. Okay, let me take it to a different workbook. See if I don't know why it's not highlighted. It is not but this you need to highlight all this, then choose the one that you prefer. Okay. The document has been opened in compatible. So to use this feature, convert your document to a new file by clicking the file tab and then convert. Okay. Okay, file tab, and then what is the convert? Okay, options, convert. I didn't see it. So what I'm gonna do is to put this in a different workbook. Let me put this, take it to that other workbook. Okay. I'm gonna take it to the one we were using yesterday. Copy this, go to this part, and then paste it here. Okay. Now, let me highlight it again. It's highlighted, insert, pie chart. Okay, this should be showing up. Okay, this pie chart is for degrees. Let me get the right label for it. Type of degree. So this shows the degree confirmed in 2007. Okay, the degree is confirmed in 2007. Okay, I'm taking it back here. Degrees, type of degree. Degree is confirmed. Degree is confirmed in 2007. Okay, you can see each color. See this color. See, bachelor's is the red color. Associate is the blue color. Then light blue is the doctorate. Then green is the master's. So now, I don't know how your screen shows this, but here this place should be showing where you can choose. Click on any of these to put the numbers in. Mine is, I don't know why, for some reason mine is not showing, and it's telling me this command is currently disabled. This document have opened in a compatibility mode. To use this feature, convert your document to a new file format by clicking file and then clicking okay. I click on file and then I didn't see the convert here. The only thing I can do is to draw it in a totally new document. So I'm going to open a new Excel document because it must show us. Okay, good. paste it here. Now again, I highlight it. Can you see the screen? I pasted it in a new document. I open a new Excel document. So I highlighted it. Then again, click on the charts. Good. Now it is showing. Can you see it? Can you see it? Good. I can see this. So now you can choose. I can choose any of these. I can choose this. Once you click on it, it will put the percentages in. So degrees conferred. I think it's conferred in 2007. Now, this is it right there. So if you are doing a project, you can, and you want to add this to what you are typing, you can click here and Control C, you copy it, and let us assume that this is your project, the one we have here. Suppose this is your project. You can paste it anywhere in the project. Control V, and you paste it there. Then you begin typing. For example, when you look at this, you can see that majority of the degrees conferred in 2007 were bachelor's degree. Okay. Interpretation of this. According to the pie charts, majority of 51, you can just say 51% of the degrees conferred in 2007 are bachelor's degree. And followed by, next is the associate. Then, and so on and so forth. Questions?
No, sir.
I was totally lost, but okay.
Say it again. Hello? I didn't get your question. Can you ask the question again, please?
She didn't ask a question. You can move on.
But you didn't ask the question. Okay. All right. Now let's go back to our notebook. Okay. Now, next is the Pareto chart. Pareto chart is like the bar chart. Bar chart is just that you put them in order before you draw the graph. So, like if you look at this example here, it said in a recent year, the retail industry lost 36 billion in inventory shrinkage. Inventory shrinkage is the loss of the inventory through breakage, pilferage, shoplifting, and so on. So the causes of inventory shrinkage are administrative error, employee theft, which is 15.9, then shoplifting, 12.7 billion, then, and the vendor fraud. Use Pareto chart to organize this data. So what you're gonna do for Pareto chart is you put them in order from largest to smallest. Largest here is shoplifting. So I'm gonna write shoplifting is 12.7 billion. 12.7 billion. Okay. Next is followed by, actually the largest is the employee theft, which is 15.9 billion. So employee theft, 15.9 billion. Then followed by shoplifting. Then next one is the administrative error. So admin error is 5.4 billion. 5.4 billion. Then we have then vendor fraud. Vendor fraud is more or less, which is 1.4 billion. So to put this in a Pareto chart, first thing you do is to put them in order. See, Once you put them in order, then you can now draw the charts. As you can have all of them here. 1, 2, 3, 4. I mean, I'm missing one of them. Yeah, I'm not missing one of them. Then the unknown. They didn't have anything for the unknown. So if you go to the Excel, I'm gonna close this part. Okay. So when you go to the Excel, we have.
Stop sharing, by the way. Okay, thank you.
So you go to Excel, you can put the first of all, you have employee theft. Employee theft. And that is
So the highest is administrative error, right?
no. Administrative error is the second to lowest. Look at it right here.
Let me see.
See, administrative error is 5.4 billion.
Oh, I got you. My bad. Thank you.
So this place we have the 15.9 billion. I'll make this big. Okay, make it bigger. Okay, you can see better now. The next is the shoplifting. I want to finish on time so that you can have more time to practice. 12.7 billion. Next is the administrative error. Admin error, which is 5.4 billion. Then we have the last vendor fraud. Which is 1.4 billion. So now you see the Pareto chart, just highlight this and then insert, okay, to give you right there. So let me look at the correct title for it, which is going to be, the correct title will be, said the causes of inventory shrinkage is the loss of, okay, the causes of inventory, okay, good. Causes of inventory leakage. Where are we? The causes of inventory leakage. Okay. Now let us format this. Add the axis. One amount in billions of dollars. Okay. So they have the causes. You can see that the employee theft is the cost, is the highest cost of inventory leakage, followed by shoplifting, and then vendor error. This is the type, or I call it the cost. Yeah. And like I showed you, can always copy this and paste it in your project. Questions on this? We're almost done.
Can you, so when you go to insert, can you click insert again? I wanted to see where the chart is.
Sure. So you highlight it. Now look at the insert here. So they give you the options. See, this is one you click and then choose the chart. Okay. So after that, you can then format.
You could choose any chart, right?
You have to choose the one that is stable for this, yeah, for the problem. Okay. Yes.
Okay, thank you.
Any other question? Okay, yeah, good. Now, like I say, we're almost finishing, almost done. Let us see if we can go back to our notebook. Then last is the scatter plot. We're not going to worry about scatter plot now because we do scatter plot when we do regression. So let us look at the one we call the time series graph. So this are you have the data set indexed by time. So so all you have to do is to, you know how you do your graphing. Let me see, graphing in your algebra class, where you have the x-axis, you know. Let's say this, for example, what we are doing in this case is they give us a set of data where you have the year and the subscriber, the number of telephone subscribers. Now you cannot graph the subscribers and the average bill in the same graph because they have different units. This one is only in numbers, millions of subscribers, but this one is in amount, in dollars. So they can't be put in the same graph because they have different units. So we can graph only this year and the subscribers, or the year and the amount they spent in their telephone bill. So let us choose year and subscribers. For example, let me show you an example of how I closed it. I think I closed it by mistake. Oh, yeah, give me 1 minute. I'm gonna open it again. I closed our notebook by mistake, so I'm gonna open it again. Just give me a minute. I'm gonna go here. Notebook is right here. Okay, I'm gonna open it. Good, and then I will share it. Good. So I'm gonna share it with you guys. Okay, I'm gonna go all the way down. Here we are. Yep, this is where we are. You can see the screen, right?
Yeah.
Okay, good. Now, so I'm gonna show you, a refresher on how you do your graphing. Yeah, you can have your subscribers here. Subscribers. Okay, in millions. Okay, then you have your year, which goes from, I think it goes from 1998 to 2008. Okay, so we have, you can start from here, 1998, 1999, 2000, 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008. So these are the year. Okay. Now you can, put your X and Y axis. This is a Y axis for the subscribers. Okay. And this is the year, if you remember from your algebra class. Okay. Now you can put the numbers in for the millions and then start plotting the graph. But the good thing is that I don't require it here since we are going to be using the technology to do that. But this is the principle behind it. You have your Y and S axis, and then you start plotting your points. Remember, every point have two parts, the S and Y axis, and the S and Y coordinates. See, this is your X, this is your Y. So, but I'm going to use the Excel to simplify this. So let me open our Excel. Give me a minute. I'm going to open and share it where I have it. Okay, excuse me. And then I'll close some of the items we have so we can have enough room Okay. So I'm gonna close this. Okay. That's more I wanna close. This is one I opened here. Let's just do this one and then we'll round up. Now, this is it. I put them here. You can see the subscribers that we have and the million. So you can just highlight this and then insert the line graph. This gives us the it's giving us the wrong way. Okay. So what I'm gonna do is to try this. A little trick I use with Excel, just a small little trick. Okay. Shouldn't be disappearing. Okay, let me try a little trick. This will not disappear. It will give us what we want. Okay. Okay. Because sometimes Excel can act funny. Then use a small trick, play a small trick on it. That's this particular. When we come to test of hypothesis, you understand why I'm using this trick. Excel doesn't have any platform for testing for single tests, one sample test. So what we do, we trick Excel as if we are doing a two test difference of mean test, and then from there we can now tweak it a little bit, and it will give us what we want for one for single sample test. So that's what I'm doing. And let's see what this will give us. We'll plot it. See, they're giving us what we want. Oh, but we're not looking for a histogram. We're looking for a line graph. Sorry, my mistake. This is the line graph. So if you see, give us the graph right away. See, when I tried it, the regular one, it was giving us the wrong things. But when I use a little trick and it gives us what you want, you can see for each year the number of subscribers. Telephone subscribers by year. Now, we have number of subscribers here, a number of subscribers. And this is the year, of course. You can see that it shows an upward trend here. So that means number of telephone subscribers are increasing by year. See, going up. Questions?
No.
So I think that's conclude our lecture today. And next week we will start with our see this is the same graph I just drew. You can see where it was drawn. So that, and the graph shows that the number of subscribers have been increasing since 2008. So this concludes. Next week I'm going to upload the lecture 3, which will be data description. I think because of the Independence Day, I think Monday is a public holiday, I believe.
Yeah,
am I right or wrong?
Or in June 5.
I think Monday is public holidays. Am I right or wrong?
You're right, sir.
4th of July is celebrated.
Confirm. If there's any change, I will let you know through remind. Please, if you receive the text message I sent last night, please respond so that you can be in and receive my updates. Okay?
Professor Ozzy, I haven't received your text message. You want me to put my number on?
Oh, you haven't received it?
No. You want me to direct message you my number?
Yeah. Let me have it. Maybe I typed it wrong. That's why you didn't receive it. Because I sent it to everybody. So let me have it.
Yeah, I put it in the chat. Look at it.
Oh, okay, good, very good. So let me just check your attendance, and then you can leave. And
Okay.
you all have a nice holiday. Don't drink too much, okay?
Okay. You too, Professor Ozzy. Don't drink too much.
I will not, I promise. When you see me next week, I will look as sober as I am today, okay?
Okay.
All right, so let me see. I got Binta here, right? I got Bista, right?
Yeah.
You're the one that sent me your cell phone, right?
Yes.
I have your name now, so you can leave. Who is I got Rita Ford.
Yes.
I got Kent, Taijie Kent. So if I call you, you can leave. Vanessa, I got Vanessa. Vanessa, you can go.
Have a great day, Professor Ozzy.
Have a great day, everybody.
Enjoy you too. Enjoy your weekend.
Dolly, I got Dolly.
Professor, enjoy your weekend.
Yes, I'm here.
You too.
Professor OG, I've never given you my phone number.
I'm
I get one.
I did not send you my phone number. Was I supposed to do that?
Please do, so I can send you the message so you can be receiving my texts.
Okay.
Yeah.
You want me to send it through Canvas or
Canvas or Chinese? It doesn't matter. Whichever one, so long as I got it.
Canvas or
Professor,
what?
I just mine through the chat.
Oh,
Okay, send it to chat. Good.
oh, I sent
Vanessa,
it.
Tiffany Walker. Tiffany. I got
Yes,
Tiffany.
and I sent my number through the chat. You see it?
Let me check this chat now. Okay, well, just 1 minute. I'm gonna check it now. Oops, I keep messing with this stuff. So you guys grew up with technology. I didn't. So I try to catch up. You know what I mean? Yeah. Okay. I got it.
You were doing a great job.
I got it. Okay. I got it now. Oops, excuse me. I'm looking for your names. Who else I haven't called yet? Austin. You can go now. It's Austin. Tell Kyle. Kyle, tell you can go. Who else? Sherry, Debbie, you can go now. Debbie, and Miagia. Who's Miagia? You here? Miagia? I think I called you already. All right. Takia Docket. You there? Miss Takia.
Yeah.
You can go now. Enjoy your weekend.
Maisha, I think that's her name, said her mic doesn't work.
Yeah.
Maisha, I think her name is Maisha. It popped up on the
Maisha.
screen. She said her mic doesn't work.
It's
Oh, okay.
Austin. Yeah.
Okay. Lucky, let me check her. I think I checked her already. I saw her name anyway.
You got me, Professor, I can go?
Worker, right?
Yeah.
I got yours since last year. I'm playing with you.
You don't want to call the drink this weekend.
You to enjoy. So I think I got everybody here. I'm Donson. I don't see Donson.
Mine? Do you have mine? Dolly.
Right?
Dolly, sir. Yes, sir.
I got Dolly already.
Okay, and I received a text message asking for my birthday and
No. I don't want their birthday.
okay.
Just reply yes. That's what I need.
Okay, just yes. Okay.
Yeah.
To 81 81010.
Just that message you got. Reply yes. Type yes and reply. That's it.
Okay. Okay. Thank you.
Okay. And
Vanessa-
Professor OG, I just sent you my telephone number. This is Vanessa.
Okay, Vanessa. Okay, yeah, I'll take care of it now. Okay.
Okay. All right. Have a lovely weekend.
I got two Vanessas. I got Vanessa M and then Vanessa Moloch. Is that the same person?
Yes, that's the same person. I switched to my telephone so that I could talk on the computer. I don't have any. I don't have any voice.
Okay.
All right. So on the phone, M, on the computer is Moloch.
Okay. Got you.
All right, sir.
You
Have a
guys
good
enjoy.
weekend.
You too.
Be
Let me
careful
take-
out there.
I will. And you too.
Thank you.
Let me get all these numbers so I can resend this. That is it again. All right, I got.
All right.
I'm here. I have no question. Good night.
Hold on. Let me just give me 1 minute. 263. Okay. 1607. Okay. Yes. What were you saying?
I was just saying good night.
Oh, good night. Okay. Okay. Good night.
Good night. Bye-bye.
Okay. And next is Untitled. Okay. This one is 443. 653. 4161. Okay, got it. Okay. Now I will end the class.